So for this problem, right, we're looking at a projectile fired at the time t 0.0 seconds from 0 point edge of a cliff with initial velocity components of the velocity initial 30 meters per second with vy 100 meters per second. The projectile rises and then falls into the sea at point P. The time of flight of the projectile is 25 seconds, right? And we can tell that we'll just right off the start off with this equation that we'll do this one right here, which is equals 30t. This is the equation they give us at the beginning, right? That's the equation they gave us in the beginning, right? This is a component that doesn't change, right? Since we see here that this x is constant, right? The person's right here for this projectile that's fired, and we know that Vx, right? Since we just stated it right now, is 30. That isn't x. I'm sorry. Just, my phone is broken. And the Vy, right? It says it's 100 meters per second, right? And it will be 100 minus 10t, 10t, right? So let me rewrite this. And before I rewrite it, right, we want to find t at 15. So we'll plug in 15 for t. So let's rewrite this now. And it'll be 100 minus 10 times 15, which will be 150, right? Which eventually will turn into negative 50. Then from negative 50, we have to, let me erase this again. So we know, now I know it's negative 50, right? For 15, right? 15. Sorry, I'm sick. Then the next equation we have to use, right? Because we're trying to find the magnitude of velocity at that time, right? So to find the magnitude, we plug it into this equation, which is Vx squared plus Vy squared square rooted. And the numbers we would plug in for them, right? We said that the Vx was 30, and that we said the Vy, since we just found it right now, is a negative 50. And after we plug it in, right? After we plug it in, we're going to be left with this right here. Sorry. Which will then eventually equal to 58 meters per second. And the closest one we have is A. The answer will be A, 56.